A lot of people actually ask as well, what will be the skills needed in the
That was going to
future?
be my next question.
It's going to be very difficult to predict. Well, it's going to be easy to predict in the next 5 years, but we're talking about maybe 15, 20 years. It becomes more challenging because in the next 10 years, probably the majority of the jobs don't exist today yet. So it will be jobs that will be created depending on what technologies, depending on what ecosystems are coming across. But I think that the skills that needs to be developed in everybody now is like before, people used to go to college, study a degree, and then that's it. They never went back to college. They never read anything or research papers. I think that fact is completely gone now. So you need to constantly be learning, constantly be adaptive. You need to be able to change and get out of your comfort zone and try new things.
That's Omar Hatamleh, the Chief Innovation Officer of Engineering and Executive Director of the Space Studies Program at NASA. He was formerly the Deputy Chief Scientist at NASA and has been with the company for about 21 years. In case you haven't heard of them, NASA is a U.S. government agency that was established in 1958, and their purpose is to pioneer the future in space exploration, scientific discovery, and aeronautics research. In today's discussion, you will hear how Omar has seen NASA change over the last 21 years, how they plan to use technology like 3D printing and AI in the future, and his thoughts on which technologies are overhyped. Omar also gives us a sneak peek into how NASA works, including how they tackle problems, how they build effective teams and deal with failure, and how they focus on creative thinking. It is a fascinating discussion.
One of the elements when you're doing brainstorming is we teach people how to not judge any idea beforehand. So if, for example, if people are brainstorming and somebody comes up with an idea and I say, no, I don't like this idea, this is not going to work. And then that person comes up with a second idea and I said, you know what, it's probably not that's not what I was thinking about. And then the third time, that person is not going to contribute anything. He's going to shut down.
This is Jacob Morgan, best-selling author, speaker, and futurist. Welcome to the Future of Work podcast, where every week I speak with C-level executives, business leaders, and authors to explore how the workplace is changing and what the future of work is going to look like. The goal of this show is to give you the insights, the ideas, and the inspiration to help future-proof your career and your organization. If you want to get access to more content, such as podcast transcriptions and information on working with me or having me keynote your next event, you can visit my website at thefutureorganization.com. If you want to take your education even further by getting access to courses that explore these themes in more depth, then check out futureofworkuniversity.com. Also, if you get a few seconds, please rate and review the podcast on iTunes or whatever your preferred channel is. It really helps the show, and I personally appreciate it, since the podcast does take quite a bit of effort to produce. In case you're interested in sponsoring the podcast or working with me, my email is jacob@thefutureorganization.com. Hello, everyone. Welcome to another episode of the Future of Work podcast. My guest today is Omar Hatamleh. He is the Executive Director of the Space Studies Program at the International Space University, and he's also the Chief Innovation Officer of Engineering at NASA. And from what I understand, you also used to be the former Chief Scientist at NASA, right? The Deputy Chief Scientist?
Yes, actually, I was a Deputy Chief Scientist at NASA Ames in 2014, and that was a very exciting position there, being in the Silicon Valley and doing a lot of work, and it has to do with astronomy and the CubeSats and quantum computers. So it was very exciting times.
Oh, man. Okay, so we have lots of stuff to talk about. But before we jump into all that, why don't you give people a little bit of background information about you, maybe some of the things that you're currently involved in, what you do as the Chief Innovation Officer, and also maybe a little bit of background about NASA.
Yeah, no, definitely. First of all, thanks for having me, Jacob. I appreciate the time here, the opportunity. So I've been with NASA for about 21 years. I started as a structures engineer, and my last three positions was Deputy Chief Scientist and then Chief Innovation Officer for Engineering. And now currently I'm the Executive Director for the Space Studies Program, which is an international program that involves people from tens of countries to talk about the interdisciplinarity of space and how to engage from different levels. So after that, the Chief Innovation Officer basically it involves encouraging different divergent ways of thinking, using open innovation, getting people outside of the comfort zones, using design thinking. So there's a lot of elements. The basic thing is having people change their mentality, changing the culture. I think that's the biggest challenge that everybody faces. But little by little, I think you start making progress, start using some of the tools available in the market, and try to form alliances or collaborations to find synergies between different industries, different governments, academia, and form an ecosystem actually to be able to encourage very different and diverse ways of thinking to encourage new things to happen.
And maybe for the few people that have not heard of NASA, I honestly don't think anybody has not heard of NASA, but just to be safe, maybe you can give us a little bit of background information about NASA, who you guys are, what you guys are doing.
Well, NASA is a government agency. It's been established in 1958, and it basically leads the research for the nation in aeronautics and aerospace. And I think we have about 10 centers, ranging from Washington, D.C., where the headquarters is, and we have several research centers, like the one in Glenn, the one in Ames Research Center, and then we have the operational centers, like the Human Space Flight Center, which the one I'm from, Johnson Space Center, that manages all the engineering, the mission control, the astronaut training, and then we have centers like Kennedy Space Center, basically, where we have the actual launch and operations to be able to put missions together and launch them into space. So it's a big organization, and we do a lot of research in astronomy, in Earth observation, and planets, and aeronautics, and rocketry, and exploring deep space exploration. So it's a vast array of things into that.
I'm sure a lot of people are curious, and I'm quite curious about this as well. Is applying for a job at NASA just like applying for a job at any company? I mean, job application, interviews, come into the office. I mean, is it the same process to get a job at NASA as it is, for example, at IBM or Coca-Cola?
Yeah, it's slightly different. It follows the federal government organization, the same rules. So typically, most of the hires come from people who have done internships or cooperative education, where they spend several semesters rotating in different departments. So you get to know these people, you get to know their work ethics, they're good to know their capabilities, and then we have sometimes critical hires where you have to hire some people in certain disciplines that there is a need for. But it's the same essential guidelines that any federal agency in the government. It's open to the public, depending what it is, and follows the same rules and regulations.
And you said you've been there for 21 years.
Yeah, exactly.
So I'm sure you've seen the company change since your time there. And you know, a lot of people are talking about the future of work and jobs and all that sort of stuff. How have you seen NASA change, or how have you seen even just work changing during your time there?
Well, let me tell you about the whole environment, how it's changed. So, for example, we just had the 50th anniversary of the Apollo program. And at that time, it was a competitive environment where actually nations were competing for a race to go to the moon. And then it changed basically from a competitive environment into more collaborative environment, which is basically the space station. We have several nations came together and had this huge complex endeavor of putting the space station in orbit, and being one of the most complex scientific platforms that we have ever built. And then actually we have a third dimension now, which is basically getting in the commercial startups and the small companies, and getting a new dimension to the whole thing now. So what we're trying to do now is basically like SpaceX. There is a lot of technologies that was developed at NASA. We have a lot of expertise. So we're passing along, we're enabling the commercial sector to be able to have an impact and creating more jobs, creating better economy, getting them the technology and the knowledge and helping them. So combined with the amazing corporate knowledge that we have and the amazing innovation and agility that the corporate sector has, I think that creates an excellent environment to create more jobs, improve the economy, and so on. And then what we need to do is basically we're going to free up our resources and go explore deep space. Our next goal is going to be, for example, going to the moon again by 2024. And from there, we're going to go to Mars, hopefully soon after that, in the decade or so.
You mentioned going from a competitive to a collaborative environment, and I feel like a lot of organizations are doing this as well. Why do you think that's the case? Why was it always about competition before, and now it's much more about teams and working together? What happened?
Well, let's look at how technology is evolving. So before, when you had the technology in certain sector, typically that technology only was applicable to that specific sector. Let me give you an example of 3D printer or 3D manufacturing, for example. People thought when that technology came out, it was only done for producing components, for manufacturing parts, but in fact it turned out to be something that spans all across various industries. It goes, for example, now the food industry is using it substantially. I've heard of some startups. You can actually program your 3D printer when you're going home and being able to print a pizza or something, and you get it ready when you go home. It's being used in the clothing industry, so there's a lot of research, a lot of startups as well, and companies are working into creating clothing and garments using the 3D printing technologies. So in the future, for example, most of the clothing will be tailored specifically to your needs. So you'll be able to buy the file or be able to design your specific things and be able to print your own specific garments. And then we'll have obviously more electronics embedded in them and so on. And in the medical field, so recently we're able to print 3D printed organs based on the genetic composition of the person, so the risk of being rejected is almost negligible. And also producing casts, producing portions of bones specifically 100% tailored to the dimensions and the contours of the specific bones. In construction, for example, right now we have houses, construction equipment. They could construct a house with 3D printing capability in a few days at a fraction of the cost that used to cost building a conventional home. So that's giving access to so many people and in so many different locations. And for us, of course, when we go to Mars, for example, it's a very far destination from Earth. So it is impossible for us to take all the spares or all the equipment that's needed for us to be there for substantial periods of time. So what we're working on right now is developing 3D printing capabilities, and hopefully you'll be able to leverage on the in situ resources and regolith to be able to print any components that we need to use there. So you can see, for example, this is a technology, and it's no longer applicable to one field. It's applicable across all different fields. And I can tell you so many different examples like that. So nowadays, it makes sense to collaborate between various industries because, first of all, if you have the same problem, you can actually split the cost. You can bring new resources into it. You can have different ways of thinking about it. So the creativity and innovation that comes because we have very diverse group of people from different industries, it creates completely different designs and different solutions that will be impossible to create in a single organization.
Very cool. Okay, so you mentioned all sorts of different changes that we're seeing and different technologies. So now I'm really curious, if you were to look, let's say, 10 years in the future, what do you think the world is going to be like? You mentioned 3D printing of clothing, for example. Yeah. I'm sure you have all sorts of ideas in your head around what the world would look like. Share your thoughts on that.
No, absolutely. But before we talk about what we go on, I think that the environment, the conventional environment of the work, I think is starting to change substantially. For example, there's research indicates that approximately by the year 2027 in the United States, over 50% of the employees will be freelancers. And they've done studies indicating that, for example, if you have one employee and you're paying him $100,000, the productivity that you actually get from that person is on the average of 40%. So you're paying for 40%, you're paying for 100% and getting 40% product or productivity from that person. So the freelancing is starting to become more popular. Employees are preferring it, and employers are preferring it. So it's a commonality between both. And it seems like the conventional work environments is shifting as well. But let's talk about a little bit now about the future and with the technology and all that stuff. And I think to give you the baseline, let's start talking about the population increase. So if you look, for example, at the beginning of human evolution until the year 1800, the whole population of the Earth was less than 1 billion. And in the span of almost 200 years, we went from almost less than 1 billion to 7.5 billion people. And that trend will continue increasing. The estimates are reaching about 10 by the year 2050. So we have a vast population increase, and that's actually increasing the population on the Earth. But let's look at the technologies and how the technology is going to have an impact on this, on the work and the population and so on. If you look at artificial intelligence, which is some topic that people are starting to talk about a lot, it's becoming a very hot topic. And just to give you quickly, maybe I can give a few words about how the evolution, because the artificial intelligence.
Yes, please.
Artificial intelligence is nothing new. It's been in existence since the 50s. But recently, somehow, everything became very different. And the reason for that is for 3 pillars, I believe. So the first one is the algorithms. So we have now much more advanced algorithms that go much deeper, multi-layer, compared to the basic archaic algorithms that you used to have a few decades away. So the basic knowledge of putting the things together, that reinforced learning and so on, so becoming much more complex. The second thing is the computational power. Typical computers, they go through in series. So you do a calculation, you solve it, you go to the next one. But the gaming industry actually came up, invested heavily in that, and created GPUs, which could have 5,000 or 6,000 cores. So basically, you can run 5,000 or 6,000 operations at the same time instantaneously. So that creates a system that's substantially faster and can do much more complex times at a fraction of the time. And of course, the third element is going to be the big data. So none of that stuff is going to be usable without having the big data where the systems can learn from and be the feedstock and the boundary conditions to go through it, and being able to determine and tweak the analysis and the results. So between all these three now, I think we're in the phase where we call weak artificial intelligence, which is some people estimated that it's equivalent to human 5 or 6 years old. It's like at the beginning of the infancy. So, and you can see all these advances that you see is still in the weak form. In about 7 to 10 years, estimates are saying we're going to get to general artificial intelligence, where you have cognitive capabilities of maybe an adult human brain. And then in about maybe 20 or 30 years, we'll get to the super artificial intelligence. And that's when people are kind of nervous about, because there's a lot of uncertainties in that field. So all these things are contributing substantially to changing the landscape of the employment. Look, for example, I can talk to you as an engineer. If you want to design something, it takes you weeks or sometimes months. You have to draft it, to design it, to build the 3D modeling, to run the finite element modeling, to do the testing, the vibration, the thermal. So that takes you weeks or months even. So with a very advanced artificial intelligence system, you can run all these things, maybe hundreds of thousands of cases or even millions of cases in a few seconds, and can actually tell you which cases are the best ones for which condition and so on. So medical doctors, for example, recently with the kind of basic algorithms that we have, in several cases, the artificial intelligence was able to outpass and surpass radiologists and dermatologists in the determination of the diagnosis. The same thing with Wall Street. I think they done comparison with the very seasoned investors, and they put him head-to-head with an artificial intelligence system, which is of today's capabilities. And I think it was slightly ahead of the person that was there for decades with a vast amount of experience. Same thing with lawyers, same thing with almost any career, right? The same thing is humans themselves. I think we're becoming much more efficient. We're starting to have much more electronics in us. One of the technologies, for example, we have at NASA, we developed with GM, is a glove that enables people to be able to do repetitive tasks without being tired. So instead of a person doing the job for a certain amount of time and getting tired, you can do it for much longer. So all these things are telling you that you need less and less people to be able to perform the jobs and the tasks that needed to do that. And mission control, for example, we used to have many more people in the back rooms controlling and helping, aiding the people in the front room. And with the advancements of technologies, you see less and less people doing that and being able to take advantage of the amazing computational capabilities that are available. So all that stuff doesn't mean that people are not going to have jobs, but there's going to be a shift, obviously. There's going to be a big shift because initially there's going to be a phase where will be jobs for people, because technologies typically create new jobs, right? It's just the problem is, and we had this discussion before a long time ago with the Industrial Revolution. People were concerned that the emergence of these new automation and machineries were able to displace a lot of jobs, and that wasn't the case. That was very different. Obviously, it was actually more jobs were created, and wasn't an impact. I think the problem we have right now is we're competing on the intellectual level as well. So it's no longer on manual labor, but the intellectual capabilities. So that actually opens a new dimension of things that we never explored before, and makes things a little bit different.
I have so many questions for you about what you just said.
Yeah.
I was trying to take notes as you were going through all that. All right. So the first thing that popped into mind, tell me about this glove. What sort of glove is it? What sort of routine work are we talking about here? And also, I'm really curious, are there other areas, and I'm sure there are, inside of NASA that you can share where you are using AI, and what are those areas, and what are you guys doing?
Yeah, so the glove, for example, if I give you the example, if you can grab a tennis ball and squeeze a tennis ball for until you get tired, probably you get tired after 10, 15, 20 times. So this glove, it has some actuators embedded in it. It enable you maybe to do it for 100, 150, 200 times without having an impact on your ligaments and your muscles and your joints. So you'll be able to extend the reach. And this is just an example of what can be done not only now, but in the future. It's beyond the imaginations of things. So artificial intelligence, for example, if I can give you some examples, astronomy. So astronomers, they have a lot of data points that actually they collect from dishes, and they have to go through it manually. Sometimes it takes a long periods of time. So with the emergence of artificial intelligence, they can go through all these kind of things, and all this boring manual labor that they have to go on, repetitive manual labor, can be done with a decent artificial intelligence. So the amount of work will be reduced substantially, and they can concentrate on more fun things as opposed to just doing repetitive work. And could be done also artificial intelligence, like I said, in designing things and finding trends and connecting dots in ways that were difficult to find before. So I think it's pervasive technology that's going to be embedded in every single industry, every single aspect of our life substantially.
The other thing that you mentioned, which I thought was interesting, and actually I've given a couple of talks on AI, so I've spent some time looking at the history of AI, but a lot of people don't know this, and you mentioned this, that AI is not new, and it has been around since the 50s. Yeah. So can you talk a little bit about that? Because I feel like a lot of people assume that this is a new concept, new idea, it came out of nowhere, and everyone's talking about it, but it's been decades.
Yeah, no, definitely. Well, first of all, in the 50s, the basic assumptions and the algorithms, the mathematical assumptions that go into these complex mathematical models were very basic. And, if you're going to try to emulate some of the human brain, it's extremely complex way of doing things. So first of all, the basic models were very simple, and they were completely erroneous. They weren't not even remotely close to what they were supposed to do. And then the computational power that we had was very, very basic as well. So it took forever. So for a long time, people actually gave up on these kind of things. They said this is not working properly. And until recently, a bunch of researchers came in and started putting a lot of research, a lot of funding into it. And in the last decade or even a little bit more, I've seen amazing transformations in these mathematical models and algorithms that were able to do much better job than what we had before. And like I said, that combined with the three elements now, with the amazing computational power. So the cool thing about the gaming industry is it's not only developed these kind of things, but they developed it in a way for the gaming industry that actually it's very cheap. So a lot of labs around the world can use it now. So you don't have to be a lab with a lot of funding, with a lot of resources, because these things are available at decent prices. So it opens the doors for so many universities, for so many labs and researchers around the world to be able to be engaged in that field. And the more people get engaged into that area, then the better results, the better accuracy, the better progress you try to make in this field. And then that big data. Every day we have tremendous amount of data being created. So if you want to teach, for example, an algorithm how to identify a cat, then you have to show that algorithm, it has to go through thousands or hundreds of thousands of pictures, right? In order for that algorithm to be able to recognize the cat, that this is a cat, this is so on. So the big data is a third dimension that we definitely need to be able to make the progress. And all these three things were not available in the 50s. And that's why the synergy and that center of gravity is improving substantially.
Okay. And so when you look at the world of AI, do you think there's a lot of hype in it, or is a lot of the concern and discussion around it real? So, for example, the elimination of jobs, being able to create a kind of a human intelligence by 2030 or 2040. We talk about driverless car. I mean, is all that sort of stuff actually going to happen, or do you think it's maybe a little bit overblown and everything will just be fine in the future?
Yeah, well, there is actually both. I think, in my opinion, it could be both happening. So first of all, I mean, the work week. The work week right now, the standard is 40 hours, 5 days a week. And in my opinion, this is almost like a random number, because right now, eventually, you can do so many things, and you don't need to do the job in so many days and so many hours per day. So I think the transition will be essentially is to having less amount of days, working less hours, and being able, hopefully, people spend more time doing the things that they enjoy, and being able to capitalize on the technological transformation and advances to be able to improve their lives, the quality of their lives. I think that would be the best one. But the more we keep moving forward, and like we said, with the big population increase and getting the advanced technologies beyond imagination, I think that's where the biggest impact will be. And even the current economic models, I think they won't be sustainable anymore. When you have huge population increases, we have a lot of billions of people potentially, if that is the case, potentially without having jobs, then the current economic models might be breaking down. So we need to look into what is going to be the future economical models. And people, to be able psychologically to be satisfied, they need to feel that they're having self-worth, they're contributing, they're producing something. So that's all these things. So it's going to be from the psychological, from the technological, from the economical. It's going to be something that policymakers, CEOs needs to be working substantially on that and be able to predict what's going to happen the next 5, 10, 20, 30 years according to what advances are we trying to see. Another thing, Jacob, I think we need to definitely build the bridge between industry, academia, and government, because all of us need to be working together. And if technology is improving so fast, if somebody's studying a technical degree in 5 years, potentially some of the things you study in the first year might be a little bit slightly different by the time you graduate. So we need to be constant rejuvenation, constant update and cycle, and the loop between all these people, the academia, industry, and government, to be able to produce the better workforce in the future. And a lot of people actually ask as well, what will be the skills needed in the
That was going to be my next question.
Yeah. It's going to be very difficult to predict. It's going to be easy to predict in the next 5 years, but we're talking about maybe 15, 20 years. It becomes more challenging because in the next 10 years, probably the majority of the jobs don't exist today yet. So it will be jobs that will be created depending on what technologies, depending on what ecosystems are coming across. But I think that the skills that needs to be developed in everybody now is like before, people used to go to college, study a degree, and then that's it. They never went back to college. They never read anything or research papers. I think that fact is completely gone now. So you need to constantly be learning, constantly be adaptive. You need to be able to change and get out of your comfort zone and try new things. So you need to develop also jobs. The jobs that will be more difficult to impact is job that necessitates or needs to be creative. have emotional intelligence, probably having decision-making capabilities. So any job in that field might be a little bit more difficult to penetrate initially. We don't know what's going to happen in the long future, but traits like that will be needed. Just the adaptability, learning constantly, and being able to adapt to the new environments. Because if you look at the work environment now, people that have been working for 15, 20 years, it's very difficult to change the ways of the way they do the job. It's very, very difficult to do that. So I think this mindset will need to change, and people need to be more adaptable, more flexible, in order to be able to be sustainable and maintain this technological changes that we're having.
I have one more technology question for you, and then maybe we can switch into some of the non-technology stuff, like ways of thinking. I mean, you mentioned design thinking. And the last technology question is more around which technologies are you paying attention to that you think are going to have the greatest impact? So you mentioned quantum computing. We talked about AI. You mentioned 3D printing.
Yeah.
Which areas are you paying attention to the most, and why? And which ones do you think are maybe a little bit overhyped?
Okay, well, I can give you 5 technologies, and I think definitely going to be big impacts. And the thing I'm looking into right now, look at the internet, for example. It was a basic technology, but out of that technology, we have almost $7.5 trillion in economy. And look how many millions of jobs were created because of that technology. So now we have artificial intelligence, we have drones, we have autonomous systems, we have quantum computers, for example, we have 3D printing. So these are basic technologies, but I'm interested in knowing what are going to be the ecosystems that are going to be developed around all these basic technologies, because all of these will need support systems, support technologies, support startups, support industries. Let me give you an example of driverless cars, right? So a driverless car is going to have substantial impacts on the positive and on the negative as well. It's going to create jobs. It's going to take a lot of jobs from different places. For example, the driverless cars, when you talk about manufacturing, car manufacturing. So if, on average, people in the United States have 2 cars or 3 cars per family. But if you have a car that's autonomous, it can go from one place to another by itself, then obviously you don't need 3 cars. You only need 1 car, and the car will take the members of the family and be able to pick them up and be coming. Because right now we only drive to the work destination, and we leave the car in the parking lot for the most of the day. So you can have 1 car that takes care of the whole family and drives by itself, and immediately you reduce the amount of cars between 50 to 70%. And then the discussions are actually around the neighborhoods, having fleets of cars for a neighborhood or so on. So we're talking about substantial reduction in the amount of cars that needs to be produced. So the question is, what's going to be the impact on these car manufacturing people? Insurance, for example, if these cars will never get into an accident, they're 100% safe eventually, and it will never be stolen. So what is the role of insurance companies in these kind of things? And most of the insurance companies, it's a big source of income for them, is insuring these automobiles and cars and vehicles. So if you only need to insure a fraction and then eventually maybe reduced, so what's going to impact on the jobs from these fields? Hotels, for example, if you right now you can drive, for example, from San Francisco to Los Angeles. It's about maybe 6-hour drive or so. So instead of sleeping and staying at Los Angeles, if you have to have a meeting and come back, you can have your meeting and come back in your car. You can sleep while your car is driving you back. So what's the impact on the hotel industry and the garages? But at the same time, these technologies are going to be creating new jobs. Because they're going to be servicing companies that will need to be adapted and work to be able to help these technologies. For example, if you're going to stay in your car for prolonged periods of time, you probably need to eat. So maybe there's some way of maybe printing food or being able to produce food during the long drives. Yeah, maybe mobile office, better communication and mobile office environments. Maybe entertainment systems that are beyond what we have right now. Security, obviously. So cybersecurity will be essential, will be completely paramount for the success of the driverless cars. So we'll be creating more jobs in that field. So you can say this is the technology, for example, single one, and it's creating jobs, but at the same time, it's displacing so many different jobs at the same time. So the question is, where's the balance gonna fit eventually? Is it gonna be more in the losing jobs or more in creating jobs? And that's the questions we'll have to see actually as we go along.
Yeah, that's a very good question. And I feel like A lot of people today are focused on the elimination of jobs, and they never talk about the creation of jobs. And I think that's why there's so much negativity around it, because we're very obsessed with the jobs that will be removed, but not with all the jobs that are going to be created. So I'm really glad that you brought that up. I wanted to switch gears a little bit and talk a little bit around how you encourage different types of thinking, because in your LinkedIn profile, which I thought you had a very interesting way that you described your role, and you said empower the organization to create creative thinking to tackle moonshot challenges and develop capacity to innovate.
Yeah.
So let's start with the first part of that, which is to empower the organization to develop creative thinking. How do you develop creative thinking? Are there exercises or trainings that you guys do internally?
Sure. Okay, so one of the things that I do is I teach something called design thinking workshop. And so what I try to instill in people is completely think outside of the box. Don't take the normal assumptions. And I've done an investigation actually in teaching the class so many times. So one of the elements that I ask to people to design is one of them is designing a wallet. And then I put a picture of the wallet and I tell them to come up with an idea how to design the wallet. And then 100% of the times people design a conventional wallet like the one you were showing them. So they basically, it was anchoring the thinking process because they were seeing that wallet and that was everything they were concentrating on. And then I for the last few classes I did, I didn't put the picture, I said design a wallet, and the wallet could be anything. And the ideas were completely creative, completely out of the box. That was the most creative classes I've taught is the last few ones. When I took that picture and the conditioning of the image, by encouraging people to think completely in divergent ways and not condition themselves about what's going on in front of them.
And this is a Stanford exercise, right? I think
exactly.
Okay.
Yep. Exactly. So there's multiple ones. The wallet is a good one because it applies to everybody. Everybody knows the same. Everybody has a wallet of some sense, right? And you can do the same thing to create. Talk about cities, how to design cities, how to design products. It's just a way basically of involving the customer in the loop, because a lot of times people do designs from one area and they don't involve the customer in the loop, and that's when you start failing into things.
And for people that want to see this, I think they can go into the Stanford website, right, to see the wallet design challenge. I think it's like a public template that somebody can download.
Yes, exactly.
Okay.
And there is, like I said, the wallet is one of them. The methodology is being developed between Harvard and Stanford. They have amazing, literature. But the examples, there's tons of examples, and one of the ones that I like to use sometimes is the wallet because, like I said, it's something common between everybody. Everybody you have a wallet, and it's simple to pass the message and teach the class and the workshop to gain the idea.
Okay, so you sounds like you teach employees this concept, but how does it become applicable into sort of real world how they're doing their jobs? Because it's one thing obviously to do something in a class; it's another thing to actually take those concepts and apply them in the real world when they're doing work for NASA. Yeah. So how do you translate that?
Okay, well, it's something very important, and I think it's an impediment to a lot of organization, is something called groupthink. So when you have, for example, 5 engineers, or you have 5 business people, you have 5 medical doctors, then it's like having one person, because all of these people are gonna have the same mentality, the same way of thinking. So one of the ways I encourage people to do is actually diversify the group as much as possible, and that's when you start having creative ideas completely creative. So imagine if you have an engineer, you have a scientist, you have a business person, you have a lawyer, you even have an accountant, an artist. So the ideas you'll be able to get will be 100% different. And then if you have people from different generations as well, people from different cultural backgrounds, it's completely diverse, the ideas we'll be able to get. So that's something very essential, very important, is diversifying your group as much as possible. That's when you start getting ideas outside of the box.
I'm glad that you mentioned that, because I have a new book that's coming out in January of next year on the future leader. And I talk a lot about this idea of diverse teams, which I don't think we pay enough attention to in the business world today. But for a leader, I guess, how do you ensure that diverse team? Are there certain criteria that you look at? If you're not a part of a diverse team, do you encourage employees at NASA to speak up and say, hey, everybody on this team is the same and looks the same. Maybe we should get some other people in here. Or how do you encourage that so that people don't get in trouble, so they're not scared to speak up?
Yeah, no, it's a trial and error, and hopefully you keep trying until you get something that works out. But talking about speaking out, for example, so one of the elements in when you're doing brainstorming is we teach people how to not judge any idea beforehand. So, if, for example, if people are brainstorming and somebody comes up with an idea, and I say, no, I don't like this idea, this is not going to work, and then that person comes up with a second idea. And I said, you know what? It's probably not that's not what I was thinking about. And then the third time, that person is not going to contribute anything. He's going to shut down. So what we do is we try to encourage everybody to come up with ideas, and we don't judge anything. We said, yeah, I like your idea, and actually I can combine it with that person. I can combine it, this idea combined into a third concept. So it's even the way you run these kind of things and the way you deal with people. I think it has a lot of difference. It makes a big difference in the way you harvest things. There's a lot of psychological elements that go into creativity and innovation as well.
How do you guys structure your teams? Is it, I know, for example, Amazon, they have their famous like 2 pizza rule where no team should be bigger than 2 large pizzas can feed. Do you structure your teams in any particular way?
It depends. It's NASA's big organization, right? And every directorate and every organization does it in a different way. Some people, try to leverage a lot on open innovation. Open innovation, by the way, has been incredible. So right now, for example, if you have a challenge, if you have a problem, not only you can leverage of the employees that you have in-house, but you can put a challenge and actually have hundreds of thousands of people looking at it and producing solutions that are, it will be something incredible. One of the actually cases that I read recently is a potato chip manufacturing company was having an issue with the extra grease, and they were struggling because to remove the grease from the chips, you need to shake the potato, and that results in the potatoes broken into pieces, and it's not attractive when you open a bag of chips with broken pieces, right? So they put an open challenge on one of these open innovation platforms, and the results, actually the best solution came from a violinist. So the violinist actually came up with the tone that actually was hitting the natural frequency of the grease, and it was being removed from the chip without impacting the potato chip itself. And so you can see it's like you can come up with amazing solutions. You don't have to have as many employees working on things because you can leverage on the huge amount of vast resources that you have outside of your organization with the emergence of these new open innovation platforms.
Do you guys do that internally at NASA as well?
Yeah, exactly. With that, we do some internally. We use some of them out externally. So that's like I said, the power of crowdsourcing has been incredible in every single thing that we do. And not only in companies like Uber, like Facebook, like everything. And open innovation, I think, has been incredible in bringing crowdsources to help with solutions and technologies.
Okay, so it sounds like part of your job, as you said, you encourage this kind of unique way of thinking, and the main way you do that is through these workshops, these programs that you teach around thinking out of the box, and also through diversity. Are those the 2 kind of main pillars you use?
Also, there's other ones. For example, the more you read about articles, recent articles, read books. So we do also a series of once a week, we have brown bag lunches where we talk about maybe an article that has to do with innovation, with creativity. For example, there is so many cases I can tell you that don't involve spending a penny in solving big problems. There is, for example, an electric bike company in the Netherlands. And they were having about a rate of 60 to 70% return because it's a very sensitive equipment with a lot of electronics. And people in the shipping companies, when they were seeing that they were shipping bicycles, they were being rough in transporting them from one place to another. And that's actually the company almost ran out of business because most of these components and bicycles were coming back to them damaged. So one of the employees came up with a brilliant idea. Said, why don't you actually print a picture of a TV, an LCD TV on the box of the bicycle, and that gives the impression to the shipping people that they're transporting a TV. So by doing that, it's a simple idea and almost eliminated completely the problem that they had.
That's awesome. I love that idea.
Another example is there's also a small town in one of the European countries. They were having problems with speeding cars. And they put a lot of fines, big fines, and it wasn't having an impact on reducing the speeding cars. And there was a lot of kids playing, so they were concerned about potential accidents. So one of the people in the council, the city council, came up with an idea. Said instead of punishing people for speeding, why don't we actually have we actually encourage people that don't do this damage or don't do speeding. We encourage them by positive reinforcement. So they started recording all the plates of the cars. And the ones that were not speeding, they put them into a pool. And at the end of the month, they got a check from the people that were speeding for the collections of the money that they collected from people who were speeding. So by doing reinforced actually behavior as opposed to taking money from the people, that also solved the problem substantially. And we can talk for a long time. I have so many examples about that. But sometimes innovation doesn't require you to spend so much money. It just could be a simple idea. It could have a big impact on solving a big problem that you've been having for years.
Yeah, no, those are great stories. So I guess for people listening, maybe for leaders or even for individuals, if they want to encourage this kind of innovative thinking, you recommend those two things, kind of teaching design thinking in new ways of approaching problems and also focusing on building diverse teams.
Yes, and also reading as much as possible cases, innovation cases, creativity cases from different magazines, innovation magazines, and also I noticed it's very essential who you surround yourself with. If you have creative people in your organization and these people are talking and showing what they're doing, it's a contagious thing. So people would definitely start thinking differently. So the more examples, for example, you show to people, they start rewiring the way of thinking, and they start thinking about things in a different way completely. So it's who do you engage with, who you surround yourself with, what literature do you read, how diverse your team is, how do you capitalize on the tools that we have today in open innovation, and at the end it has to do with leadership as well, right? So a lot of organizations, for example, say I want to be innovative, I want to create so many innovative products, and a lot of employees come out and they come up with these concepts, but everything stops in the middle. Typically, middle management is what stops everything. And the reason is because they're afraid that if they actually take risk, that their jobs will be at risk. And I found out that the best way to tackle these kind of things is by actually the executives having in the performance evaluation mandatory actions that this is something you need to do, but at the same time have their backup, right? Have their back. So if something happens, they need to understand it's not going to impact their job. It's encouraged to take risk. And if something happens, your job is not going to be at risk. And when people feel comfortable, then you have a whole cycle happening from the top to the bottom, and we have things happening in organizations. Otherwise, the whole system will break through. So it's the leadership, the organization, the way you think about things. It's a puzzle. It's like a Lego. It's like different pieces that have to come together to be able to come up with the best results.
The other thing that you talked about is this idea of moonshots. So can you talk about what those are and how you encourage people to reach for those?
So moonshots, and essentially it came from going to the moon. So at that time, it was seemingly like an impossible task to go to the moon with the technology we had, and with the amount of determination and work and the technology development and funding, we're able to do something that seems completely impossible. So that's where the term moonshot came, and moonshot is something where you create multiple orders of value compared to, or they call it sometimes 10x. It's like instead of having maybe 10%, 20%, or 30% improvement, you create something that's actually 10 times better than what you have right now. And that's why to do that, you have to think completely different. You have to go back to the basic, to the drawing board and start coming up with completely new things. Look at, for example, at the smartphones when it first came out. That was completely a moonshot almost, because people used to have simple phones. So the smartphones, the creation of the smartphones, actually, that was, in my opinion, one of the moonshots that changed completely these industries and creating this revolution in communication that we have today. Same thing in medicine, same thing in any field as well. But so unfortunately, these moonshots are very much more difficult, and the majority of it will fail. But if you have some of them that succeed, that will change completely 100% your industry.
How do you deal with failure at NASA?
Yeah, well, failure, and the thing is, I see failures in two different ways. I mean, obviously, when you have people, astronaut on a rocket going to launch, If you fail, now that's absolutely not acceptable. But there's a lot of times, a lot of way you can fail before you get there, and you learn a lot from it actually. And just to give you an example about failure and about errors and from nature. So like the monarch butterflies, for example. So there was a genetic error in from one generation to another. And that thing enabled the larva to eat some milkweed, which is a poisonous plant. So because of that, when the larva ate that one, because of the genetic composition, genetic error that happens, allowed them to do that without poisoning them. So when it transformed into monarch butterflies, then the predators learned over time that these butterflies are poisonous, and they just left them alone. So from mistake, it created something that actually essentially saved the whole species. So there is a lot of things and benefits from failing and from making mistakes, and as long as you learn from them. And you don't repeat them again. I think it's not a bad thing. It's just the problem is at the end, collectively, if you keep making mistakes at the end, then that's absolutely not acceptable. Like when it comes to sending people and humans into different places.
When employees at NASA fail, and of course we're not talking about sending a human into space, but maybe during the course of regular projects or things like they're working on here on Earth, if an employee fails, how do you deal with it? They made a big mistake. What happens to that employee? How do you then treat it or address it?
Yeah, that's like any other organization. Depend who's the employee, who's their manager, is he a leader, is he a manager, what kind of mistake did he make? Did he make mistakes, multiple times? So it's very dynamic, right? It's multiple dimensional. It's very difficult. But I can tell you about my personal experience, dealing with people. If they make a mistake, it's okay. It's like we can learn from it, and we try to actually have corrective action and make sure that never happens again. And we share these mistakes with other groups. So actually, we can learn from each other. And I don't see it as a bad thing initially, because if you actually gonna be punishing people making mistakes, then you're gonna be able to restrict people from doing a lot, because you're gonna be actually afraid to take any risk. And without taking risk, you can't do much. You have to take risk in order to be pushing the envelope and doing something that's gonna be different.
Do you guys have a certain risk framework that you use to help you decide where to make your investments or which decisions to make, or how do you approach that? Yeah,
there is definitely. NASA has a huge corporate knowledge in these kind of things, and there's tons and tons of people. That's what they do for a living, and sometimes they buy risk by investing more in certain areas or not. So it's a big field. Obviously, we deal with it every day, and because the space business is very risky business, and no matter what you do at the end, you have to accept a certain element of risk. Otherwise, you're in the wrong business.
Yeah, there's always always going to be risk. Are you able to share any of that framework, like some of the steps that go into it, or some of the things that you think about?
Yeah, there is a lot of analysis, failure modes and effect analysis, hazard analysis. So depending what component you design, you can see, for example, what are the failure modes for that kind of thing. How critical they are, how many redundancies do you have. So it's a big framework that people can do, and it's big specialists that work on these fields and areas.
Okay. The other thing I know that you spend a lot of time thinking about is innovation. So how do you define innovation? So what is it, and how do you encourage your team, your employees to be innovative?
Yeah. So innovation, in my opinion, is basically using the resources that you have to create new value. It's so not necessarily. Sometimes people refer to innovation when you create something that you spend maybe tens of millions to develop a new technology. Yeah, obviously that is an element of innovation, but innovation could be just using some of the resources that you have right now and create something completely different that creates better value than what you had before. Or could be, thinking of an idea that actually can solve a problem like the one we alluded to earlier before. So innovation has a lot of segments, and all collectively is how do you make better value into the organization? How do you make things better, cheaper, create something that is much better than what it used to be before? I think all that stuff collectively, it's an element of innovation.
Okay. And yeah, I think innovation is a huge topic. And sometimes I think people confuse sort of invention with innovation.
Yeah, no, exactly. It's an invention could be an element of that, but it's
not necessarily the same thing.
No, definitely.
Okay.
Innovation could be, something is not an invention, but an invention could be part of an innovation. So it's intertwined.
What is it like to work at NASA? So is it free food, open spaces, gym
No.
memberships, or what's the environment like there?
No, it's very exciting. Obviously, you're working on the leading edge technology to sending people into different planets or to study the latest sciences in different fields. So it's very exciting from that perspective. But essentially, it's a government agency, right? So it's not like sometimes when I go visit Google, we visit Facebook and some of these high-tech companies, and you get the free food. The environment is very different. Obviously, we cannot do that in government organizations, right? But each ones have advantages and disadvantages. But it's very exciting job, very exciting organization. I think it's one of the ones with the highest job satisfaction across the federal agencies. And it's an incredible. Everybody there is very motivated, very hard worker, and together, I think it's amazing things are happening.
What do you think people listening to this who are not working for engineering organizations or space companies like NASA, what can they learn from some of the approaches or the ways of thinking that you guys have internally? So, for people out there who are, traditional business environment, business jobs, what advice would you give to them based on what you've learned at NASA?
Yeah. I think it goes both ways, actually, because I one of the things I like to do every month is go to completely different company that's outside of my industry, and I see how they run their business, what governance models they have, and I try to learn from them. So I think it's something. It's with both the directional. We learn because we don't do everything the best. We're not the best at everything, obviously, but a lot of the things are being done much better in different industries, in different organizations. So I think the best way to do is try to have benchmarking. So collectively, the people from different industries, maybe from different government organizations, start having benchmarking and try to learn from each other and see how you guys deal with failures? How do you deal with creating new value? How do we learn from each other? Can we, learn from your mistakes? Can we learn from your successes? Can we work together to solve some of these kind of things? So I think that is the most essential element, is kind of actually do it in a big scale and benchmark and learn from each other.
Do you think there are any practices that you guys use at NASA that other companies don't? Whether it's decision making, whether it is an approach that you have to problem solving, maybe it's even a way that you approach leadership or a perk that you have. Is there anything that you think is unique to NASA that no other company out there has or does?
That's a very good question. Obviously we're very good at systems engineering. I think we're the JC, for example, Johnson Space Center is one of the best in the world at systems engineering. How to put different systems and components together to produce some big vehicle or big thing. We're very good, for example, at risk analysis, at safety and mission assurance, because we have to deal with that every single day. And also, but it depends on the organization. For example, if you're talking about the flight director, then it's the governance model is very different than a person, for example, in a design organization. So depending on which organization you are, it's going to be very different, the governance models and the way you deal with the management and so on. But yeah, if I had to choose two, I would say definitely systems engineering and safety analysis, risk analysis, and all these kind of things, since these are at the core of what we do, and at least at Johnson Space Center. But in other places, they do more research and science and stuff like that.
Earlier, you talked about changing mentality, and you talked about culture. And I know this is also a struggle for a lot of organizations. So what do you do to change someone's mentality or way of thinking? And I suppose this comes in a lot of different ways. It could be for leaders who have a very hard time adapting to new ways of working. So for example, I think you mentioned 21 years ago, it used to be very competitive. Now it's collaborative. I'm sure there are some leaders who just had a very hard time changing that way of thinking. Or maybe it's an employee who's having a hard time changing their way of thinking. What do you do? How do you get people to see things differently and sort of make that mental switch? Yeah, I think that's one of the most difficult cultural elements that people struggle with. And one of the things that people typically, if you are in innovation field, when people tell you, "Hey, it's not broken, why should I fix it?"
So it's very, very difficult to deal with kind of things. So in my opinion, I see it two approaches you can do for that. The first one is to try to incrementally try to push little changes to into what they're trying to do, and show the people that you're dealing with that by doing this little incremental change compared to what was used to happen, look at how much value and how much benefit and how much advances you were able to do. And other one is actually to do it more drastically, where you actually have bigger measures and bigger changes, and then when things they see the value at the end result of it, people start embracing more and more the change. But it has to do with so many different elements. Younger generations obviously is more susceptible to being more creative and doing things and changing things. If somebody's been doing it the same job for 20, 30 years or 40 years, it becomes much more challenging to be able to change the mentality or the way they do things. But in these cases, you have to do it incrementally at very small steps and eventually show the value from being able to embrace new ways of doing business.
Well, you've been at NASA for 21 years, you said. How do you keep yourself excited about the job and keep yourself engaged in the work that you're doing?
Well, it's the thing is every few years you need to look for a new challenge, obviously, because every time, for example, you got an assignment, you're very excited, you have so much energy, you're actually questioning things, and actually these questions might bring so much value because as an outsider you're coming in with different perspectives. So people there have been immersed into that environment that are difficult sometimes for them to see what's happening. So it's when you're coming and with this energy and everything is exciting and you learn. But then I think people need to switch jobs maybe after every 3 or 4 years to keep the momentum going, to keep you excited, to keep you challenged, right? And being able to keep things interesting. Otherwise, eventually you reach a point where it becomes stagnant and there's not much progress being made. So I think, in my opinion, it needs to change every 3 to 4 years to be able to keep the momentum going.
Well, I know we are just about out of time. Is there anything else that you want listeners to know, or any last parting words of wisdom that you have for people who are tuning in?
No, I think eventually we have a very exciting future. It's going to be incredible, the amount of advances we've had in technology, how much benefits it's having to society. And I think it's overall, all these technologies will be for the better, right? There's going to be some challenges, some risk, but I think all these elements will be able to have make people maybe live longer, have better economic lives, better incomes, more comfortable, societies. So I think overall it will be a benefit, and it's incredible to see how much advances we've done in the last 100 years. When the main transportation was horses, now we're going to the moon, and we're talking about driverless cars or even driverless flying cars. So imagine what the future will hold in 20 or 25 years from now. I think it's going to be something very interesting.
Well, where can people go to learn more about you or some of the work that you're doing or some of the projects that NASA has going on? I mean, anything that you want to mention for people to check out, please feel free to do so.
Yeah, no, it's, NASA has an amazing website, outlines all the missions that we're doing in terms of going missions to Mars or new satellites missions or new science, new technologies. We also have a spin-off book that we produce every single year that shows you the technologies that were developed for space, how actually could be applicable to create economies and jobs on Earth. And that tells you what the value from space. So sometimes people ask, why are you spending so much money in space? Where actually we need it for the economy. But most of the research has indicated that for every dollar you spend on space, the return is from $3 to $6 in terms of creating value, creating jobs, and creating new technologies that creates new businesses. So you have to look into all these kind of elements as well.
Well, Omar, thank you so much for taking time out of your day to join me. I found the conversation fascinating, and I hope people enjoyed it as well. So thank you very much.
Thank you very much, Jacob.
And thanks everyone for tuning in. Again, my guest has been Omar Hatamleh. He's the Executive Director of the Space Studies Program at the International Space University, and he's also the Chief Innovation Officer of Engineering at NASA. He's on LinkedIn. You can find him there, and also make sure to check out the NASA website. I will see all of you next week.